So hey everyone, welcome back to my channel. This is Lakshay here. So today we're gonna start with a lead code question number 22, which says generate parenthesis. So what this question says, let's read. So it says given n pairs of parentheses, write a function to generate all combination of well-formed parentheses. So here we will be given a integer. Suppose here it is given n equals to 3. That means our string will we have to generate all the combination that would have three opening braces and three closing braces, as you can see here. Okay, so if there will be one, then it means that we can only have one possibility of one closing and one opening, but here three, so we can have three opening, then three closing, then two opening, one closing, one opening, one closing, then one again closing. So like this we can have to make all the combinations that are possible, but we have to keep one thing in mind, that it should be a proper, means it cannot be invalid. Like it cannot be like this, like it is. This is also that the total number of parentheses are here, also the total number of parentheses are one, like this. Here is also two opening and two closing, but this is not a valid parenthesis. Valid can be like this or like this. These are the valid parentheses here. That's why this can't be true. So we have to also keep this thing in mind, that what is the valid sequence and what is the invalid sequence. So how can we approach this problem? So we can approach this problem with the help of DFS here, which is also recursion technique. So let's see by taking the example. Okay. So let's suppose here our n was 3. What this means? It means that we have to insert 3 opening braces and 3 closing braces. Okay, then only our string will be complete. Okay, so how can we do that? Let us suppose here at starting we have open equals to 0, close equals to 0, and our n is equals to 3. Okay, so how can we do that? So with the help of DFS, first of all we will do add a opening braces. Okay, like this. So we add a opening braces. Now our open is 1 and our close is still 2. Now what we can do? Now again we will call for the function, and now our opening braces is like this. It is 2 and our closing is still 0. Then again next step, our close opening braces is 3 and now our 0. Now we can see that our open is not smaller than n, means it have reached its limit. So now we will start adding it closing braces here, like this. Okay, like this. Now 3 and 1. Now we'll keep on adding closing braces till our closing braces is smaller than our open. Okay, now we can see that it's still smaller. We will add another. Okay, now we can see it is still smaller. We can add another. Okay, so now we can see this is like this. So now let's jump down to the code to understand this more clearly, because it's not easy to understand. So let's, with the help of code, let's understand it more clearly. So we can see here we are having n equals to 3, as we know earlier. This is our code. First of all, what we are doing, we are creating a string, a vector of strings that consists of result, means result, like this, and it is empty at starting. And then we are calling our DFS from here, so it is now calling it here. Not what we will do. So it says if open equals to close and then close is equals to n. So at starting we have passed open as 0 here and close as also as 0, and we have also declared a string here which is empty at starting, which will be our subsets, all the subset strings that will be our final strings later on, and n, that is our total length of our, that will be given our integer, and the resultant that will be stored. So it is passed here. So we can see that if open equals to close, yes, true, but our close is not equals to n. That's why we will not go under this condition, and it's jumped down here. It says if open is smaller than n, means our open is smaller than n. So we will call our DFS for open plus 1 like this, and it will add to our string this will be added to our string, and our open is now 1 and our close is still 0. Okay, and then we are calling this function again. Okay, so now it is called again. From here we are here, and now this is our values. Now we can see that now our open is 1 and close is 0, so they are not equal. That means this condition again fails, and it jumps to here again, and then it again calls our DFS for open plus 1 like this as we did earlier. So now we are having 2, and it also adding a string like this, and then it is 0 again. Then again same for 3 also. But now what we will see after 3, that now our open is not smaller than n. So what will happen? We know, so that means this will not run this statement, and it will jump directly to here, and we can see close is smaller than n here because close is 0 and see this is 3. So then it will add another this like this, and then again call the DFS. Then again DFS will be called, and it will again see that open is already have reached n. Then this condition will not run, and this will run. Then again it will be added like this. This is how all this will be added, and when it goes back, so it sees here that after DFS have returned, then here another case will be there, that now this, and then there will be case like this, because now our second statement will be running, because our first statement have already run and it has given our output. So now then second statement will run from here, then it will again add a closing bracket, then again call our DFS. Then from here also two condition will be there, adding another braces like this, and another cases is closing braces. Now from here on we have another two cases. This is where at the end we will get all our desired string, all the combination. Okay, this is how we are getting all our strings like this. After this, let's suppose here we are at the end. Here our open equals to close equals to 3. That is our end. So this condition satisfies, and it will be pushed back to our result. So now our result will be containing this string. Okay, cool. This is how it is gonna happen. Then it returns from this function. Then again it is called for the another value. Then again, this is how it's gonna work, and we will get all our desired string at the end, and it will be under our result, and we will simply return at the end. So this returns, and at the end we will return our resultant string. That will be our final answer. Okay, so that's it. You must try this recursion yourself only, that then only you can understand this. Otherwise it's a kind of tricky question, but must know three steps. They are the major three steps for the question. First is only add opening braces if open, our value of open is smaller than n. Second is only add closing braces if close is smaller than n. Okay, no, close is more than open, then only we will add. And the last step is that when our open is equal to close and it is equals to n, then we have to stop. Using these three steps you will finally get your answer. Okay, now let's discuss the time complexity. So our time complexity is big O of 4 to the power n upon root n, and space complexity is also big O of 4 to the power n upon root n. This is also very hard to discuss the time complexity, so I prefer that you must study it from ChatGPT, because that will explain much better, because it's a trickier one. So that's it. Thanks for watching. See you in next video. Bye bye.